Hi, my name is Tim Steiner, and this is my first time presenting at CarolinaCon. A little about me, I am a cybersecurity consultant in North Carolina, and I've been working in the industry for many years now, focusing in offensive security. And today I'm going to be presenting on one of my favorite topics, which is red teaming. And we're going to be focusing on the method of command and control known as DNS tunneling. So no matter how tightly you restrict outbound access from your network, you probably allow DNS queries to at least one server. Adversaries can abuse this hole in your firewall to exfiltrate data and establish a stealthy method of command and control. It's very difficult to block and difficult to detect. Here's our agenda for today. I will be giving some background on DNS tunneling and showing how it works, and then we're going to go through a demo where we take a look at actual DNS packets so you can see specifically how data is tunneled inside of DNS requests. We'll take a look at the examples from the MITRE attack framework and also the recent SolarWinds Sunburst payload. And then we will go into some specifics such as how blue teams can mitigate the DNS tunneling threat and how red teams can evade those mitigations. All right, so an overview of DNS tunneling. DNS, what is it? Why do we need it? So DNS is one of the oldest parts of the internet. It's one of the most important pieces that makes the internet work. Without it, whenever you wanted to browse to a website, you would have to type in an IP address. Instead of typing in google.com, you'd have to type in a number. It's kind of like if you had to remember everyone's phone number in a phone book rather than just looking it up by their name. So DNS allows us to use names. DNS stands for Domain Name System. So with this, it's going to resolve names to IP addresses. So it makes it so that one does not simply have to remember every website IP address. You can just remember the site name and you type it in and your browser does all the work for you. So this is convenient for users and it's something that's definitely needed. It's also something that can be misused by attackers and red teams. So DNS tunneling is a common method of misusing the DNS protocol to encode data inside of the DNS requests and get responses back that allow for covert communication. It's a channel where we can send and receive information, and it's not easy to detect that we're covertly communicating over that channel. So why it still works. This is an explanation I often have to give during red team presentations. Why does DNS tunneling work? Why didn't our SIM catch it? Well, why hasn't someone come up with a 100% effective way to prevent this threat? And why can't we implement that? So with DNS tunneling, even if all of your workstations are locked down and with a tight egress policy where no ports are permitted outbound and DNS is only permitted to your own internal DNS server, that still doesn't prevent DNS tunneling, because if you look at our diagram here, we have an internal network, we have a workstation who's trying to reach out to find where is password.website.com. The workstation asks the local DNS server. The local DNS server doesn't know where this is, so it asks the public DNS server, reaches out over the internet. That server doesn't know, so it reaches out to the authoritative name server, which here is our hacker-controlled name server. So you can see the packet routes through the internet, the request makes it to the attacker's server, the attacker receives the password that we asked in the DNS request. So we've been able to encode some text in a DNS request, send it across the internet to an attacker. So this is an example that's very simple. In a real-world example, we would probably have some sort of encryption or encoding of that. We wouldn't just send password across the internet. But it gives you an idea of how this works. So we're making a DNS request, it's routing throughout the internet, and it's eventually getting to our hacker server. All right, time for a demo. So on the left side of my screen here, I have a simulated Windows victim, and on the right side is our attacker view. So this is the attacker server. We'll see DNS packets come across here. And this is our Windows victim where we'll simulate running DNS tunneling commands and tests. So our Windows victim is using a Quad 9 DNS. So this does have some security features built in, but in my testing, I've not found it to prevent DNS tunneling. So let's do a quick example. The one from the diagram in the last slide. There we had password.website.com. So here we're going to do something similar. NS lookup, password.ns1.aws.-s3.net. So this is going to be the domain that I have registered for testing. So we can see that it resolves. Our DNS request goes across the internet and reaches our attacker server, and we can see password. Okay, great. So proof of concept, we can send data across the internet by using an NS lookup command. So first I'll run some commands so you can see how it looks locally. You can see that if I do the computer name variable, I get back my computer name. And I can also use the username variable to display my username. So we have some basic system information here. We have the computer name and the username. So now let's send that over a very simple DNS tunnel. In order to do that, we'll just put it into the NS lookup command. And we can see that our DNS server is DNS9, quad 9, and our request has made it to the attacker server, and we can see in clear text prepended on the DNS query is the name of our workstation. So now let's do the same thing for the username, and we can see that comes across as well. Any kind of information across the internet in a DNS packet. So we've demonstrated running commands where we can send basic system information. Next, let's try something a little bit more advanced that's closer to what an actual DNS tunneling attack tool might use. So by encoding data, we can send it as base64, and we can send anything across the network, such as encoded commands or binary files. The server side can just reverse the base64 formatting so that we get the original file or command. Now, actual DNS tunneling tools are typically going to not only use encoding but also encryption, so that the data would look just like any other random data going across the network. For sending our encoded data, we'll just do a very simple bat file. So here I'm running a bat file to send what we did in our previous example. NS lookup, send some clear text data across. And then here we'll base64 encode the same information into a file using just the built-in Windows commands. Then we'll send that across the network in an NS lookup command. So we can see the clear text information we did in the previous example. And now we can also see base64 encoded version of that. So if we were to take this base64 encoded string, so here we can just use a very simple online utility, so you can just see how that works. So decode this string turns into our original data. So base64 encoding just encodes our clear text data. There's no encryption here. Using a bat file like this isn't just good for demonstration purposes. You can actually use this for testing out an environment if you're a blue team, maybe showing your boss, hey, here's how DNS tunneling works. Or for red teamers, you could use a bat file like this as kind of a dummy payload for a phishing campaign, where proof of concept, we're able to extract sensitive information. We got code execution on the workstation, but we're not really doing anything malicious here. Okay, so here we will use the DNS Cat2 PowerShell client to run on the host. So first thing we need to do, open up PowerShell, the command we'll use to download and run the PowerShell script. I'm going to paste that in. All right, and then we're going to start our client connecting to our domain. We're going to use CNAME and AAAA types for this example. So right now we can see in our server log here that we're making requests, we're receiving responses. It's encoded data in that tunnel, and we have a session here. So using DNS cat, we can interact with that. And now we are running commands just as if we were sitting at a command prompt at the workstation. Okay, to test that out, let's run some commands. All right, we get our who am I response back, IP config. You can see the encrypted DNS packets coming across with our data as we get our data back. So it's a pretty reliable connection, and it's all encoded in these DNS requests. All right, let's exit out of that and try just using text. So now you can see in our log, we're using DNS text requests, encoding our data inside of that. Now the size limit of DNS texts are a lot larger, so for transmitting larger amounts of data is preferred. However, it's also easier to detect for blue teams. You know, if you see a ton of DNS text requests going across, that's usually not typical user behavior. Okay, so let's look at some examples. How does this work in the wild? So one good resource is the MITRE ATT&CK framework. So this is a popular source for examples of real-world attacks. The DNS tunneling method was assigned the designation of T1071. So if you search for that, you can find a lot of real-world attacks that use this method. Atomic Red Team has some examples and scripts that you can run that actually simulate those real-world methods. And if you do a breach simulation exercise, this can be a good way to test your security architecture out. See if the tactics that attackers are actually using are detected by your security controls, and find out which ones aren't. Probably the most well-known recent attack was the recent SolarWinds incident. I'm sure most of you have heard of it if you've been following security-related events. With this attack, there were multiple pieces of malware used to compromise high-profile companies and government entities. The SolarWinds Sunburst malware used a combination of DNS and HTTP/C2. So from the FireEye report, you can see some actual DNS CNAME requests, which if you remember back to our demo, these look very familiar. This is very similar to the tool that we use where we send data encoded in CNAME. This is a very interesting example of DNS tunneling. You could dig in further, taking a look at the DLL, which generated this DNS C2 and what kind of data it was sending out from the target. So we can actually do some forensics on the SolarWinds attack and take a look at the affected DLL, which is called SolarWinds Orion Core Business Layer. So this DLL has a function in it, and if it has this, then you know it's one of the affected versions. It's called Orion Improvement Business Layer. And so if it has this, inside of that is this update function, which has the source code for the attacker's DNS-C2. So using DNS-A records, they are sending data to their attacker-controlled servers. So you can find online more in-depth analysis of how this actually works. For our purposes here, we'll take a look, and I just wanted to show you a real-world example of a DNS C2 in the wild. All right, so how do we protect against DNS tunneling? Well, the NSA has recently published some guidelines on selecting a protective DNS service. These are not usually cheap. They're really good for enterprises with large budgets, but for smaller businesses, there are alternative methods that can be used. Some of these are free and open source. The paper referenced here, Detecting DNS Tunneling, is a great place to start when implementing that. For organizations that implement PDNS, it's important to remember that this is not a silver bullet, and if improperly implemented, may even not work at all. So for example, if you have a lot of remote employees, which a lot of companies do these days, their DNS requests may not even be going over the corporate network and may be using the user's home DNS server. With DNS over HTTPS, the contents of DNS can't be inspected as it's end-to-end encrypted. So whatever solution is put in place, some questions and tests need to be conducted to ensure the visibility of DNS traffic. Because if you're just monitoring the DNS traffic at your corporate network and the attacker's tunneling isn't going through your network, you're not going to see it. So what about red teams then? Well, whenever becoming a penetration tester or a red teamer, we tend to get in the mindset of we need to think like a bad guy. And sometimes we get stuck. It's hard to switch back. How you get past PDNS is making what you're doing look as legitimate as possible to blend in. So here we need to think like a good guy to act like a bad guy. We need our setup to be as close as possible to that of a legitimate website domain. Another thing to remember is that for a red team tactic to be successful, you don't really have to outrun the bear, meaning organizations typically already have to implement exceptions just to be able to conduct business. Lots of legitimate websites are somewhat shady or misconfigured because the business just doesn't have the resources to manage it. If our domain looks like a small IT company, we can probably just blend in and make a legitimate request to the web filtering solution in some cases to categorize us as something that's low risk, like computer networking site. No need to hack anything, just ask nicely, just like you were really a small IT company. So if PDNS is the barrier, we're the guy putting on our sneakers. We don't need to be the fastest runner. We just need to be able to blend in with what's already happening. We just need to run fast enough to get past other things that are moving slower than us. So if we make our website and our domain look pretty good and it's pretty trusted, it's probably going to blend in with what the organization already allows. If they have a typical setup where they allow some small businesses that may not have the best websites or domains or may not have the most trusted setup because they just don't have the bandwidth to do so. Just don't have the resources to fully manage their site. It might be somewhat misconfigured. We just need to make our domain that we're going to use look pretty good. And we need to make it blend in with what the organization already allows. So some more tips for red teams. You need to be able to adjust quickly. If PDNS is detecting your DNS C2, you have to stop and think, what is different between my DNS requests and legitimate ones? Some tools have built-in features that allow you to customize your DNS requests to make them look more legitimate, such as DNS Cat 2 from our demo and Cobalt Strike. So Cobalt Strike's malleable profiles will allow you to do things like set random delays between DNS requests, have random size of your DNS request, and always make sure to not use things that are abnormal, such as using the largest DNS text request size. That's probably not going to blend in very well. All right, digging deeper. So we just scratched the surface on a lot of these topics. DNS tunneling is a challenge, I think most would agree, to protect against. But really, there's some other things coming our way that might be even more difficult. So With the new DNS over HTTPS protocol getting more wide adoption, and this makes it even more difficult to detect DNS tunneling. If the contexts of your DNS requests are encrypted by HTTPS, then you have to have some features in place in order to even have visibility of your DNS requests. And there's already some red team tools that take advantage of this, such as the Spider Labs DOHC2. If you like this presentation and want to learn more, feel free to contact me at t@crp.to. We are local to NC and the only company that offers a free red team exercise where if we can't breach the perimeter, it's free. Thanks for your time today, and remember, the best defense is a good offensive security strategy.